All right, welcome back, guys. Just want to go ahead and finish up section 5A. Okay, so we almost got there. The last video, I just kind of ran out of steam. So the last thing we're going to look at concerns or is germane to conducting survey and opinion polls. Okay, so really any sort of polling for that matter. So remember that we tried to get an idea of how the population feels, or some characteristic of the population, by surveying or polling a sample. Okay, and of course that sample is always going to be smaller than the population, so it's not going to be the same thing. So inherent in that process is some error. Okay, the closer our sample represents the population, then the closer our results will be to the actual parameters of the population. Okay, and so because there is some inherent error in that entire process, we're going to have what's called a margin of error. And you've probably heard this before. This is most commonly used if you listen to political polling. Okay, every time that there is a political poll and the results are released, there'll be, X% favor candidate 1, Y% favor candidate 2, and then there could even be, a third category, but there will always be associated with that a margin of error. So what that margin of error really is an encapsulation of the uncertainty of the results that are yielded by the polling. Okay, so let's look at the actual definition. So it says the margin of error in a statistical study is used to describe a confidence interval that is likely to contain the true population parameter. And we find this interval by subtracting and adding whatever that margin of error is from the sample statistic obtained in the study. Okay, so the way you find the margin of error, let me give you an example. Let's say we take a poll and we find that 55% of 55% of those that we sampled favor candidate X. And there's a margin of error of 5%. So what that actually means, well, first of all, the 55%, that is our sample statistic. Okay, that's the percentage of people from our sample that actually favor this candidate that we're considering. Now, the 5% margin of error means that the true population parameter, or in other words, the true percentage of the population that favors this candidate, could range anywhere from 5 percentage points below that sample statistic to 5 percentage points above that sample statistic. So if that sample statistic is 55%, then that range could be from 50 to 60. Okay. And so anyway, once we form this confidence interval, okay, then we can associate some level of confidence and say that we are 95% or 99% positive or confident that the true population parameter, or the true percentage of individuals that favors this candidate, is somewhere within that range or within this interval. Okay. Now I'll say a couple other things here as well. The smaller the sample size, the larger the margin of error. And why is that? Because a smaller sample is not going to be as representative of the population as a larger sample. Sampling methodology can also come into play, but the thing that really has bearing on this is the sample size itself. Okay, and to understand this more, you would have to take like an intro to statistics course. But in any case, typically the larger the sample gets, the more reflective it's going to be of the actual population, and consequently the smaller that margin of error is going to be, because we can be more confident that our sample statistic is real close to what the population parameter actually is. Okay, And there's a little video that I put in Blackboard for you to watch. It deals with margin of error and how it pertained to the, I believe it was the, let's see, yeah, it was the 2008 presidential election between Barack Obama and John McCain. Okay, so it's interesting. You should watch that. All right, so the size of the margin of error is dependent upon the sample size mainly. So if the sample is very representative of the population, then it's going to have a small associated margin of error. That just means that that sample statistic is probably real close to what the population parameter actually is. And then as the sample size increases, that margin of error tends to decrease as well. And I've just told you why that is. Okay. All right, so let's look at an example here. So it says a recent poll found that 36% of Americans said that they felt uncertain about the safety of the COVID-19 vaccine and would not take it. Okay. So we polled, it doesn't say how many individuals, but we found that 36% of them were leery about the COVID-19 vaccine. So this 36% right here, this is your sample statistic. This comes from the sample. Okay. Now what we're interested in finding is what percentage of the actual population is leery of taking the COVID-19 vaccine. Okay. So if our sample is real representative of the population, then it's going to be around 36%. Okay, it could be maybe a little less or a little more, but that's when this margin of error comes into play. And it says that the margin of error was 4 percentage points. Okay. So then the question is it reasonable to claim that 1/3 of Americans will not take the vaccine? Okay. And then I just made up these statistics, by the way. All right, well, the first thing I want to do, guys, is construct my confidence interval, okay? And so this is going to be, you're going to have a lower bound, oops, and typically this confidence interval is in parentheses because it's an actual interval if you remember from your algebra classes. So you're going to have a lower bound and you're going to have an upper bound. Okay. Now, how do we find that lower and that upper bound? Well, if you look back up here at the definition, the lower bound comes from whatever that sample statistic is minus the margin of error, and then the upper bound comes from the sample statistic plus that margin of error. Okay. So you know whenever somebody says, oh, they'll cite some statistic or some estimate, and then they'll say give or take, right? Give or take a few points or whatever. Well, that's what they're talking about, is this confidence interval. Okay, so if our sample statistic is 36%, then my lower bound is going to be 36% minus the margin of error, which is 4 percentage points. Okay, and then my upper bound will be the sample statistic plus my margin of error, which is 4 percentage points. And this is going to give me an interval from 32% all the way to 40%. Okay? And so what this means is that by taking into account this margin of error, it's given us this interval, we can be very confident that the actual percentage of Americans that feel unsafe about taking the vaccine is somewhere within this interval. Okay. Now we can't be 100% sure, but we can be close to 100% sure. That's what a confidence interval is in statistics. Okay. So we're going to assume that somewhere within this interval lies the true percentage of Americans who are not going to get, basically are not going to get the vaccine. Okay. And so we need to use this to answer this question. It says, is it reasonable to claim that 1/3 of Americans are not going to take the vaccine? Well, we need to figure out what is 1/3 within this interval. Okay. Well, what is 1/3? Well, 1/3, hold on just a minute, guys. My computer froze real quick. Rectify this. Well, 1/3 as a fraction and as a decimal is, it's that 0.3 with the 3 repeating forever, okay? Now, as a percentage, if you multiply this by 100, it'll become 33.3%, okay? Well, now the question becomes, is this within this interval? And the answer is yes, okay? Roughly 33% is within this interval. So because it's within this confidence interval, then we can say, because this interval represents where the true population parameter lies, so we can say, well, because 1/3 is within this interval, then yes, it is reasonable to assume that 1/3 of Americans are not going to take the vaccine, okay? And I'm going to say it is reasonable because 1/3 lies within our confidence interval. Okay. Now, if they had said, is it reasonable to claim that 1/2 of Americans will not take the vaccine? Well, 1/2 would not be within this interval. So then it would be unreasonable to assume that. Okay. All right, so confidence intervals are interesting, guys. If you ever take our Introduction to Statistics class, you'll learn more about those and what goes into actually calculating that margin of error. Okay, so in your homework, the margin of error is just going to be given to you, along with some sample statistic. Okay, all right, and then the last thing is I put this little graphic in here. Basic steps in conducting a statistical study. Let's go over these just real quick because you will have to do one in culmination of chapters 5 and 6, but that's going to be a little while. You want to state the goals of your study. You want to determine the population that you're studying and exactly what it is that you're trying to learn about it. Okay? You're going to choose a representative sample from the population using one of those sampling methodologies that we discussed previously. You're going to collect your raw data, and you're going to summarize that data by finding sample statistics of interest, and we'll talk about these later on. These would be things like the median, the average, that we refer to as the mean. Other things like the range in the data, something called the standard deviation. And then you're going to use those sample statistics to make an inference about the population. Okay. This is the part where you let those sample statistics create a narrative for you. And then you're going to draw conclusions and determine what you learned and how it addresses your goals. Okay. And then there's a little flow chart here if you want to look at it. But anyway, guys, that pretty much concludes 5A. Like I said, there's a lot in here, a lot of terminology and a lot of concepts that you really need to understand because we'll be referring to these as we continue. All right, well, I'll let you go for now, and I'll see you in section 5B.